This is chapter 1-1, What is Physics? Physics is simply the study of the physical world. To describe the physical world, physics uses many things from mathematical equations, scientific equations, and assumptions. Take, for example, your car, your automobile, the automobile your parents drive. You've got the airbag, you've got a heating and cooling system. All those different components work together to create your car. When you think about the airbag, physicists have to look at things in terms of scientific equations like force, determine how much force impact should the airbag actually endure to be strong enough to save someone's life. So equations and such are written in order to determine the size, the material, and the such for that particular airbag. Many inventions we use every day are developed, like I said, because of physics, i.e., your refrigerator, your heating and cooling system that you have in your home, even the lights that are utilized in this school all are remnants and examples that stem from physics. We already talked about the automobile. Although it's only one vehicle, many different components in your automobile were invented by physics. You can look in your book, figure 1-1, page 4. You can see some examples. Okay, if you're looking there, you know that the battery and headlights, an example under which physics comes from, which stems from, is electromagnetism. The AC and cooling from your car is thermodynamics. Okay? Again, these are just brief examples of what physics can do. One car, many components. From the lights to the battery to the cooling, each and every separate component was calculated through mathematics or scientific equations in order to construct the automobile. In physics, there are many different names of physics. For example, if you're in your book, figure 1-1, you have the names of the different types of physics. For example, you have the mechanics, you have heat transfer, you have vibrations, you have optics, electromagnetism, relativity, and quantum mechanics. Each of those names deal with specific subjects. For example, I specifically remember when I understood in physics that it was directly related to engineering was right in my class when I took heat transfer and thermodynamics. That particular study of physics is when you begin to understand the relationship between heat and transfer rates. For example, I remember filling up ice trays. A lot of people like to use hot water. Well, the reason is the heat transfer rate for hot water to the freezer is a lot faster opposed to putting cold water in the freezer. It's a much slower transfer rate. Therefore, many people use the hot water in the freezer. An example of looking at heat transfer under that subject of heat and transfer is going to be the actual melting and freezing processes, engines, refrigerators, freezers, and so on. Okay, if you're looking at vibrations, repetitive motion would be the subject you might study. That's dealing with springs and pendulums, sounds, and so on and so forth. Now, like the other sciences with chemistry or biology, when you get ready to do research, physics does the same thing like the other sciences, meaning that it's also going to use the scientific methods of research. Okay? We should remember that there are several different methods in which you utilize to develop your scientific research. Step one, and depending on who you ask, some people do 4 steps, some people do 5. I have the 4-step process for us. Okay, but if you use a 5-step, it's fine. Step one is the observation. What problem are you trying to solve? The hypothesis. The hypothesis deals with what what's going to what's going to be the way to arrive at your answer. Okay? Your experiment is what you do in order to test your theory, your guess. Okay? Finally, the conclusion. It's a summary of your events based on what you've done after your experiment. You can either accept or reject what you've learned based on your results. If you reject it, you go back to the top. You, you look at the observation again. Then you look and see, is there a new hypothesis that you can come and develop? If you arrive at a new hypothesis, now of course you need to test or do an experiment for that particular new hypothesis that you have arrived. Some key definitions that we should definitely know are models. Models are just smaller replicas of life-size versions or objects or scenarios. Okay? The smaller replicas can be diagrams of what you plan to study. You create smaller models, they help you keep costs lower. So instead of building an actual football stadium, you might build one that's just the size of a small bathroom or what have you, just to save on material costs. Models can help you build your hypothesis. And then you have a system. A system or systems are the step you take or the procedures that you use that will cause an event to happen. Okay? And finally, we have an uncontrolled experiment. A controlled experiment is when you have many, many, many variables, but you only change one of them.